welcome back to your favorite intermediate algebra course. We're going to take a look at hyperbolas today. So we're going to graph and write some equations of hyperbolas to be our objectives. And so if you recall ellipses, when we had an ellipse, the definition of an ellipse is you could take any point on the ellipse and the summation of the distances back to the foci was a constant. Well, today, instead, when you have these foci of a hyperbola here, okay, so let's take this point P. You take any point on this hyperbola, and if you go back to each foci, so we'll call that distance 2, we'll go back to the other foci, focus there, distance 1. If you take their difference, so d2 minus d1, that's going to be a fixed constant, okay? So let's take another point. Let's go over here now. That means d2 minus d1 here is still the same constant, right? It's the exact same thing as it was before. So that's the definition, oops, I dropped that, of a hyperbola here. So let's look at some of these characteristics of it, okay? Now this first one, we're going to have, if you have your foci we're going to place the center of these hyperbolas today, the center right in the middle of your, right at your origin, okay? So if you put your focus here on the horizontal axis, okay, C distance away from the center, you see it in red here, here's your focus, here's your focus. We're going to wrap around those focus, okay? We're going to call the vertex, if you're to draw the line between the focus, you're going to intercept, grab my green here, you're going to intercept the hyperbola at these 2 points. Okay, if you draw that horizontal line between the focus. And those 2 points we're going to call the vertices. Okay, and they're a distance away from your center here. Okay. And then you've got these, so you got your vertices, you got your focus, you got this point 0b away, which comes from your equation, and 0 negative b. And if you draw this imaginary box here, okay, and you put these, you got these slant asymptotes that go right through the corner. Okay, so at the extremities, this hyperbola is going to approach those values of the slant asymptotes. It gets closer and closer to those slant asymptotes, if you can imagine that. Okay, getting closer and closer to those slant asymptotes. Okay, and that box just kind of helps us to draw that, if you will. Okay, so if your hyperbola has a horizontal transverse axis, so here's your transverse axis that you can draw. If it's a horizontal transverse axis, the transverse axis is just between the 2 vertices. There's your equation, x squared over a squared minus y squared over b squared. But if your transverse axis goes vertical, okay, so this time your focus, see how your focus are right there and right there on your vertical axis here, your y-axis on the Cartesian coordinate system. Then your equation is y squared over a squared minus x squared over b squared equals 1. Okay, so that's a little bit about these characteristics. We really just kind of got to play with these things a little bit to kind of get the feel for it. Okay, here's some other things that are of note. Those slant asymptotes, and we'll talk about this. Here's the equation for your slant asymptotes for when your transverse axis is horizontal, whereas it's y equals plus minus a over bx if your transverse axis is vertical, so the one on the right hand side. Okay, everything else has already been shown in those graphs. So let's do a problem here. Okay, draw the hyperbola given by. Okay, now you're thinking to yourself, well, it's got to either look like x squared over a squared minus y squared over b squared equals 1, or if you recall, that's your first one right there, or it's got to be this other one, y squared over a squared minus x squared over b squared equals 1. Okay, so it's one of those two there. Oops, let me erase that. Back to it here. And you notice that your x is done first, right? So you're like, well, it's going to look like this eventually. Okay, let's force it to look like that. So we need it to have a 1 on the right hand side. So we're going to go ahead and divide both sides by 144 and we'll force that. Okay, so we got equal to 1 here. And 144, 9, well, 9 goes into 9 once, 144 into 9. Let's see, that goes, what, 16 times? That goes 16 and 16 is 1. You got a 9 left over there. So we got x squared over 16 minus y squared over 9 is equal to 1. Okay, it's equal to 1. So we just reduce it. We make sure it's in that standard form here. Okay, so our transverse axis is horizontal. Okay, so if we're drawing this thing, we're like, okay, it's going to look something like that, right? Transverse axis is going to be horizontal here. All right. So now you can identify, well, my vertices are going to be at, let's identify our A, they're A distance away from the center here. So you notice A squared equals 16. So I know my A, A plus minus 4 here. So I'm 4 units. Let me redo this graph, make it a little cleaner here. My center of this thing's in the middle. My transverse axis is horizontal. My vertices are 4 units away from the center in this case. Okay, so you're thinking about this picture right here on the left-hand side. Okay, this is the one we're looking at, the hyperbola with a horizontal transverse axis. Okay, and I'm just putting my vertex on. So I'm at 4, 0. I'm at negative 4, 0 on this thing. Okay, let's go back. All right, so now we have that. We have, let's go ahead and put our b's on here. So our b squared, if you notice, is 9. So b squared is 9. So our b is 3. So I know our, we could call, whatever, we call it a covertice, but it's not really, it's not on the hyperbola. It's just going to help us with our drawing, if you will. Okay. Now we're going to figure out our foci here. Let's go back to this. If you notice, on the foci, to find our c, right down here at the bottom, instead of c squared being a squared minus b squared like with ellipses, you got to be careful with hyperbolas. It's c squared equals a squared plus b squared. Okay, c squared equals a squared plus b squared. That's going to help us find our foci. Okay, so let's find that. So number 1 is we put this thing in standard form. Number 2, let's find our foci. Our A was 4, our B was 3, C squared 16 plus 9 over 25, so C is 5, square root. So we know, and the C, if you're, or is along that, it's the extension of that transverse axis, so it's horizontal. In other words, it's right out here. You're going to wrap around. Your focus. Okay, from this vertex. Okay, so it's going to look kind of something like that there. All right. So now at this point, what I'm going to do here, if you're going back here, let's go back to this right here. You see these slant asymptotes, like this dotted line that I just made in red, right? And that one right there. What you're going to do is you're going to use that 0B point and the vertices, and you're going to draw the box, and then you'll have it go through those slant asymptotes, so through the corners of that box, and that's going to help you to draw this thing real nicely. Okay. All right, so let's draw that. here's 0, -3. Draw it up through this vertex. Okay. Let me label these 0, 3. Let me label this one. 4 zeros, that vertex right there. This focus is a 5, 0. Okay. Alright, so let's draw those slant asymptotes right through the corners of these things. Okay, so I'm going to go from this corner to that corner. Best I can here. And then I'm going to go from this corner to that corner, and this will all help me to draw this thing. Okay. And now we're going to approximate the rest of this. We're going to kind of have this hyperbola approach that. Okay, kind of like that, if you will. Move it over here on the right hand side. Whoops. Drop my eraser. Okay, and you can plug points in, of course. You know, you could pick 5, whatever, plug it into the original 9x squared minus 16y squared equals 144. You plug the 5 in, you get your points up here, plus minus y, you know, down there. So I plug in 6, you get the point here and here, and so on. Okay, but we're kind of estimating right here to save a little time. Now your slant asymptotes. Let's talk about your asymptotes for this thing. Okay. Now, if you forget that, you know, in this original, it kind of gives you that the asymptotes when your transverse axis is horizontal is that y equals plus minus b over ax, right? But you don't need to memorize that because you can write the equation of this thing, of this. Let's talk about this one that goes up and to the right here, okay? If you're writing an equation for that line, okay, this one, in fact, I'll make it nice and red here, solid. Hey, your y-intercept is 0 and you go up 3, so I'm just doing my slope, and over 4, don't you? So up b amount over a amount. So y equals up 3 over 4, 3/4 x. There's that one. Now let's do this other one. Cause to do that one, I'm going down 3, and then right 4. So my slope is -3/4 x. Okay, you see how that's both of them? Both asymptotes there. You just write the equations for those. Okay, and those asymptotes just help us to draw the hyperbola. Okay, so it's b over ax if you want to remember it that way as well. Okay, let's do another one. Draw the hyperbola given by this one. 9y squared minus 25x squared equals 225. Now notice the y squared is labeled first, followed by a minus. So you're thinking to yourself, oh, it's got to be where my transverse axis is vertical. Okay, that's where my transverse axis is vertical. So let's go back to this one. I'll show you the little picture here. Hyperbola with vertical transverse axis right there. Okay, so we're looking at that picture right above there. Okay, let's go back here. So let's force it to be in that form. So we got to get it equal to 1. So let's divide by this 225. Divide by 225. Each side by 225. Okay. Well, 225 goes into 9. Let's see, it's at 25 times. 25 and 25 once, that leaves us with a 9 right here. Of course, we got equal to 1 right there. So I got 1y squared over 25, so y squared over 25, minus a 1x squared over 9. And there we are. We're in the form y squared over a squared minus x squared over b squared equals to 1. Okay? So we can identify, so we want to put this in that standard form so I can identify a squared is 25, so our a is 5. Our b squared is 9, so our b is 3. Our transverse axis here is vertical. Okay, our transverse axis is vertical, so that's important. Let's start kind of drawing this thing here. Transverse axis is vertical, and it's 5. A is 5. Our vertex is 5 units away from the center. 1, 2, 3, 4, 5. Right there. 1, 2, 3, 4, 5. Right there. Okay, so here's our transverse axis, if you will. Okay, and now our focus, and remember this thing's going to kind of go like that, right? Focus are going to be, we're going to wrap around the focus, right? So number 2, let's find our focus now. Here's number 1, put the thing in standard form. Number 2, find our focus. Focus, c squared equals a squared plus b squared. Our a is 5, our b is 3. C squared is 25 plus 9. C squared equals 34. So C equals square root of 34. So that's between, 5 and 6, closer to 6. Almost 6. So it's about right there. Square root of 34 is about right there. And 0, comma, negative root 34 is about right there. So you see how this hyperbola wraps around those focus points, okay? So we'll say focus 0, comma, root 34. Here's our other focus. 0, negative root 34. Okay. Now our B is 3 units, not on the transverse axis, right? So there's B0, B comma 0, 3 comma 0. Here's our other one, negative 3, 0. Okay, and we're going to draw this box. Remember our little box that helps us to write the equations and draw our slant asymptotes. Okay, so let's draw our slant asymptotes. They're through these corners. Whoops, that's not very good. Draw this slant asymptote through that corner. Okay, and that helps us to draw the green hyperbola. Let me erase some of this hyperbola. Make this a little better looking. Oops, daisy. Okay, so it's kind of like that. Kind of like that. Over here again, we're approaching those slant asymptotes, right? Now let's go ahead and write the equations for those slant asymptotes. Let me extend this a little bit here. So number 3, what are the equations for those asymptotes? I'll write the equation of the line. So in this case we say, well, the equation, let me do it for this one in black right here. Okay, that asymptote. We go up 5 over 3. Up 5 over 3, 5/3 x, right? Of course, we went through the center, so there's no y-intercept there. And then if you do this other one, let's do this one. Oops. Down 5, so negative 5 over 3 to the right 3 x. So y equals plus or minus 5/3 x is the equation for our asymptotes, which in this case, if you look back at that first picture, it's a over b plus minus a over bx when your vertical, when your transverse axis is vertical. Okay, so now you kind of got a feel for these. You can always plug in some points as well to get a little more exact. Let's look here. Write an equation of the hyperbola with foci at negative a0 and a0. So let's draw that part of it. Negative a0 and a0. Here's our a0. Here's our negative a0. And you got these vertices at 6, 0, 6, 0, negative 6, 0. And we know that this thing's just going to like wrap around those foci, right? Oops, kind of missed that vertex, but anyways. So here's our A, right? Here's our C, if you will. Okay, we're trying to write an equation of this hyperbola. Now we know our transverse axis is horizontal because the transverse axis is the line between our vertices. Okay, so you're thinking about this equation right here. X squared over A squared minus Y squared over B squared equals 1. Okay, so what we need is we need the A value, which we already know is 6. We need the B value as well. So what we're going to do is we're going to solve for B. Since we know our foci, we know C. So C squared equals A squared plus B squared. So we're going to use that equation. C squared, so our C is 8. Our A was, what was it, 6? Oops, A equals, got to put a little equals in there, equals 6 squared plus B squared. So 64 is a 36 plus B squared. Subtract 36 both sides here. And you got, what is it, 28 is our B squared. Or B is the square root of 28. Okay, so B squared is 28. So now we can say, all right, let's write the equation here. X squared over A squared minus Y squared over B squared equals 1. And our A we said was 6. And our B was the square root of 28. Okay, so X squared over 6 squared minus Y squared over the square root of 28 squared is 1. X squared, whoops, X squared over 36 minus Y squared over 28 is 1. Okay, there's our equation for that hyperbola. So make sure you guys bring your questions to class. We'll see you soon.